All right. Hi, everyone. I'm Ben Actis again. You can follow me on Twitter at @BenRaw. And this one is Advanced Android Bug Bounty Skills. So again, I worked at a research lab for like 6 years. I did a lot of Android security there, mobile reversing, network sensors. Then I went to Lookout, where I worked there for a year with Tim and Emily. Emily was actually our intern. And I reversed thousands of Android and iOS apps. Then I went to Synac, where I helped build their mobile attacking toolchain. So how do you at scale reverse apps, look for flaws statically and dynamically. And I also did a lot of mobile pen testing there too. And most recently, I started at Facebook as on their red team. At night, I run a side business called Cyber Merchants of Death, which I do a lot of bug bounties for, and I do training in this area too. So thanks to Tim, he trained me at Lookout. He was actually my boss, and he hired me. What else? I used to work with Caleb, and John Sawyer helped me get my first CVE on Android. He taught me a lot. So here's the outline. I figured we'd spend about 10 minutes on kind of like amateur hour mistakes, where I wish I knew these techniques far earlier in my kind of bug bounty career, because they're little subtle things, and you're like, oh, wow, I could have got easy payouts this way. Then we're going to spend 5 to 10 minutes on web vulns that no one usually looks at least in my opinion, in mobile apps. Then 5 minutes breaking down Android's IPC model, and then another 10 minutes for kind of IPC fail-rama. So we'll just kind of go through activity fails, intent receiver failures, communicating with service failures, and then one that actually combines the web skills with an intent fail. So I think that'll be pretty neat. So amateur hour mistakes. First things, in case you're new to this or any kind of Android reversing, you get APKs or zip files. So you can unzip them just with name the APK, give it the D flag, tell it where you want to extract everything, and then you can look at stuff. You can also use APK tool with the D flag, which means decompile. I've noticed sometimes if I unzip it, I see additional files in the root directory versus APK tool. So that's on rare occasions, but I have seen that. So the first thing you want to do is check assets and res raw. This is interesting because many developers inadvertently leave things here. I have seen AWS production keys and secrets in res raw that aren't even for the app. It's actually like production login infos, which is really funny. So like in that case, the developer was like using his main kind of build home directory, and then he just like zipped everything up and shipped it to Google Play. I've seen encryption keys, Chinese poems. If that's funny, check out my hacking pressure cooker talk from B-Sides. So here's some things left in the assets. I mentioned this one. So I was taking a flight back from, I think, DEF CON, and I was joking with my friend, I bet I could find a vuln in this really crappy app by the time we got home. And I found this. So I went to assets, and I noticed this. It was called oauth.txt, smf oauth.txt, and tmoauth.txt. And it was the actual OAuth and the secret. So you could log into production infrastructure that way, which is really funny. So I sent them a disclosure notice, like a good little researcher. And then when I was prepping for this talk, I went and checked. It turns out they did patch it like 6 months ago, but it wasn't in their patch notes. So thank you. Next one, we're going to do a little Google Android 101 here just to make sure everyone's up to speed. You just Google external storage to find this. An external storage on Android is basically world readable and world writable. Google, even in their API trainings, explicitly tells you do not store sensitive information in external storage, because any other app can grab that, one, or two, if you're hooked up by ADB, you can grab that as well, right? So think of, I don't know, say you have a dating app or something where if it's saving message pictures, for example, to SD card, that would be easy loss of privacy to suck that up, right? The other issue I see a lot, which is really sad, is you should not store executable data on external storage, right? So this can be APKs, binaries, zip files. Basically, if it's going to change code, if it's going to patch code, if it's going to change program execution, you don't want to put in that read or world readable, world writable directory. So what have I seen on external storage? I've seen binary code. I've seen binary code that runs without any kind of validation, which is hilarious. User location information. the entire app sandbox, which is impressive because usually by default it shouldn't do any of that, and also log files containing user info. So all of these are bad. How I find these, I remember this was one of the questions someone asked, like how to look for certain API keys. I'll go through some of that in a few slides. The first thing I do is I check the manifest, because on Android, your manifest, it's like your table of contents. So if I see write external storage, I go, okay, the app has a permission. And a developer might have inadvertently given that permission, but let's see if that's actually used. So if I see that in the Android manifest, the highlighted yellow line that says Android.permission write external storage, then I'll do either a grep or I'll search in Jeb or IDA, whatever tool I'm using for something for it. So if you go and look at the Google APIs, you'll see it'll always start with get external, and then it's either cache.dir, file.dir, storage directory, or storage public directory. And then I just cross-reference the uses in the code to see what it's doing. So here's an example. So this one, it's a little obfuscated, which we'll get into that, but it's called write update file. And what this is doing, you can see on the little pink, or not pink, purple and yellow highlighted line, I see it called with the API environment, and then the method get external storage public directory, and it's grabbing the downloads directory. So what this is doing is saying, hey, go to the SD card where everything downloads everything, and go and get something, right? The other trick I did was I went back and looked at this and said, oh, okay, it's grabbing something called update APK. That's interesting. So then from here, I said, okay, I wonder if it installs packages. So one of the strings you can check to see if it's installing anything is this application/vnd.android.package-archive. And if you see that, it's typically a very big indicator they're going to try to install something, right? Now you're going to need a permission for that, but usually that permission will be there too. So in this case, I have someone writing binary code to the SD card, an actual APK, and installing the package. And if you're curious, it didn't do any kind of check to validate that either. So easy payout that way. So a lot of the bug bounty ones I've noticed when I do things, they'll be like, oh, like how would you detect that if you're a malicious app? And I noticed some of my proteges, they're less familiar with this little Linux, and I think the origin actually Unix command tool called iNotify. And iNotify is like I think it runs in like kernel space. And my understanding of it is it'll essentially watch directories for reads and writes. The nice thing is you don't have to write C code to interact with this on Android. They have a really sweet Java class called File Observer that'll do that for you. So the idea of this is basically tell File Observer what directory or file to watch, and it'll tell you as soon as someone writes something or changes something, right? Here's what the constructors look like. It's super simple. It's File Observer and like the path, right? And then you can do certain masks for it. Like if you want to see like really sophisticated things, like I only want to see when a file deleted or when it's first read or when it's closed being read. You can get really hardcore into that if you want. But at a basic level, you basically say, here's a file or a directory. Tell me when something changes there, right? So this is cool. So say, for example, you had an app and somehow you could invoke a state where it writes, I don't know, user debug information to the external SD card. Then you could have iNotify tell you when that write happens. Then when that write happens, you could copy that sensitive PII data out and then do something with it, right? Or another example is if it's writing to external storage, you can have iNotify watch for when the file is being written. It could watch for when the last byte is closed, you know, like we say we're done writing the update file closed, and then swap it out for something bad. That's another example. There's a ton of other code execution examples. I have the YouTube link here. I'll release the slides. These guys went through the majority of Android antivirus apps and found flaws like the ones I just described, which is really cool talk. And it's more than just you know, jars and zips and APKs. Like sometimes it was like a minor update, and they could use like a directory transversal issue with extracting the zip to overwrite particular resources that the app trusted. So check that out. Other thing, LSA flag. Really subtle thing most people sometimes forget about. If you're looking for hidden directories either for the app's internal storage or external, try it. Sometimes you'll find things. Subtle check. So now we're going to get into quote-unquote obfuscation a little bit. Tim and Jay Case did a phenomenal talk at DEF CON on this. There's like an hour talk, but I'm using this slide because they have a really concise example of the obfuscated versus non-obfuscated ProGuard looks like. ProGuard is like your vanilla obfuscation. It comes with Android Studio. It's a checkbox, or you can do it in your Gradle config, which builds your Android app. And what it does is takes all of your classes, your methods, your attributes, and the ones that it can do, it will rename that into a less human readable name, such as A, B. So you could take something that might be called, I don't know, future payment info activity, and that would become class A. And its on create or whatever they may be might become class B, and its attributes class or C, etc. Now, this sometimes intimidates people a little bit, but there's so many clues left in the application that you can still figure out what's going on, even if you're still a novice to Android. So one thing is all your imports are still there typically, right? So look at the imports at the start of a class. If you see something like android.util.base64, you're probably doing something with base64, right? So let's go down to the screenshot on the bottom. It's called private static string decryption related. Originally, this was called just B, but going through it, I was able to make some, understand what was happening here. So you see the two orange boxes highlighted. I see base64.encode to string. I looked up on the Google APIs how that works. I said, okay, you're doing encoding. Same thing within the bottom, the base64.decode. Right. So again, simple example, check your imports, and then check the method calls regarding or related to those API calls. And feel free to look them up on the Google API. It's very well documented. It can help. Here's another example. Again, this is an obfuscated one, or at least through ProGuard. It imported the Android Content PM package manager name not found exception. So in addition to your imports, look for your exceptions as well. That can be a nice telltale sign to help. So in this one, sure enough, I saw this string update file path, and I can also see that application/vnd.android.package-archive. So even though this one on the right, it's called like, the name of this method is A, and I really don't understand what the heck's going on here, I have enough knowledge that some things are going on, right? It's using these shared preferences, and the strings are providing me little clues or little breadcrumbs of what's going on here. And then if I'm a novice to Android, I can look up those APIs and then have a better understanding of what's going on. Here's another little trick. One of my coworkers, Jing at Lookout, taught me that. This is a common trick I see a lot of developers do. They'll set like a byte array to something, and then they'll go through some methods to decrypt this or cast in the state that the app can use. Super trivial to do this. Just open up Python interpreter, paste in your bytes, and then just do .join map char and bytes, and you can get what it's doing. Found a lot of API keys this way. It's really hilarious. The other this is a neat trick a lot of devs don't know. So what you can do when you build Android Studio, you can basically say, hey, I want a debug app, which basically allows anyone to debug the app without having root, and you can make log statements with this D method. That basically means debugging, right? So in the screenshot below, it's E, which means anyone should be able to see it. And how this works is, so when I make my production-ready app and I sign as production, it's going to go to Google Play, those log statements shouldn't be called. It shouldn't be written to the actual Android logcat. But they're still present in the code, which is super useful for us reversers, right? So one of the neat things there is you can go through code, even though it's not being invoked during the running because it's a production app, not a debug one, we still see that call to it. So that can help, guide us or provide breadcrumbs of what's going on in a method if we're really confused of what's going on. Identifying crypto. So this is one of the ones I think someone asked in the audience. So I threw this one up when Tim was speaking. So a few things you can look for. Look for the import statements related to your crypto, right? So does it have math big integer, security message digest, no such algorithm, crypto cipher, or the secrets key spec ones, right? And then your methods, like even if these are obfuscated, so instead of decrypt it was A, you're still going to be taking in similar patterns, either strings or byte arrays, and doing the necessary steps, right? Even in a heavily obfuscated example, I still see secret key spec, cipher, and like the local cipher stuff. So let's take a look at this bottom image here now too. We have public static string hash of plain text. So what this one's doing is essentially it's calling get hash, and the parameters of that are a bunch of additional methods which we'll go through. But essentially what it's doing is, let's see, it's calling hex to bytes on another value, and then passing into a few other methods. So this is a case where I personally find looking at the assemblies easier. So let me see if I can do this. Let's see. Yeah, I can. Perfect. So you could do a couple things here. So if you wanted to figure out this decrypted value, right, you could do a few things. So you could actually find this hex to bytes method, copy and paste it in like, you know, something Java file and compile it. You could do that. There are subtle differences on how something Java encryption versus Android encryption works. You can just look at the APIs. It's not too bad. It's just you have to make like a weird constructor and then call, but it's doable. The other trick you can do, so here's the actual assembly for this method. So let me go back. So see how we're seeing hex to bytes here, get hash, decrypt, hex to bytes again. This is the same. That one line there is all these lines here. And what we want to look at is these invoke static assembly calls, right? Which basically call a method, for lack of a better term. So what it's doing is saying, hey, call this method hex to bytes and pass in this. And then it's coming down here and say, hey, call this method encrypt hex, right? And come down here and saying hex to bytes and then call decryption. If you notice, most of the time after these invoke static calls, you see a move result object before. So whatever this function or method ends up returning, it stores it in this v4 value. So in my other talk, I talked about using debuggers. When I first started Lookout, I would like painstakingly like write all my own decryption code. And Tim was just like, don't waste your time on this, right? Just set a breakpoint here and you can get the values, right? So you could see what the value that comes back from hex to bytes is. Then you could see the value that comes back from encrypted hex, and then hex byte again, and finally decrypt, and you can get it right here. So for me, learning the debugger is such a time saver because I don't have to write a decryption script or code every single time. I just put my breakpoint right here, look at the value, and I'm golden. I think I go through more of that. Okay, so that was kind of amateur hour mistakes there. So we covered writing binary files that anyone can mess with. We covered some of the basic encryption things to look for and how to like get around some of the really weak obfuscation. So now we're going to go on the web vuln things here. So first things, I am not a wizard at web vulns. I actually asked my girlfriend when I'm stumped on these because she's better at cross-site scripting than me. But I think if a lot of people don't realize this kind of issues exist. So WebView 101, WebView is a view that displays a web page, right? So it's like an Android app and you have this little activity and inside's a view and you can render stuff from the internet. And all you need is the Android.permission internet. Okay, pretty easy. So yeah, this is cool. Devs can enable JavaScript. Now I'm imagining everyone laughing and salivating here, but it's true though. So JavaScripts are bread and butter in a lot of web apps, right? Well, yes, developers can indeed enable this. And the strings you look for is right there in the boxes. So if you see set JavaScript enabled and you're good at web vulns, you definitely want to look at this. And I've put the API on the bottom so you guys can look at more. So I'm going to go through a couple of web vuln issues that I think are funny and good examples, which is basically common mistakes, also how to grab some neat authentication mechanisms, and how to enumerate the web APIs a little bit too. So these are the options you want to look at. I got this from the Mobile Application Hackers Handbook, phenomenal book. Go check it out. Here's the strings you want to grep for. Someone was asking earlier for these. So set allow content, file access from URLs. I'll show a proof of concept later in this talk for that one. Universal access from file URLs, JavaScript enabled, plugin state, and save password. If you see these enabled, look at an activity. You might find something. So, common issue. This is a fun one. You can override methods in Java. So a developer, there's nothing stopping them from overriding the onReceived SSL error method, right? Which is bad. So this is kind of cool. So, well, it's good from a bug bounty perspective. So if a developer does this and there's any SSL errors, they'll ignore them. So if you don't know how to get around cert pinning, for example, and you see this, doesn't really matter, right? And you can find this pretty easy, right? So you look for onReceived SSL error and then SSL error handler. Easy check. So JavaScript interfaces. So this is the idea where if you want to have like JavaScript interact with your Android code in like in an interesting way, it's going to look like this. So you have your JavaScript interface, grep for that string, and then you're going to see this add interface. And in this case, we have something called JS_var. Okay, and then this one's just doing a little pop-up, right? Now this is interesting because there's something called CVE 2012-6636, or add JavaScript interface arbitrary code execution. So that JS_var that we declare in this slide right here, well, if you can get any kind of XSS, right, if you can gain control of this, you can have that then call the exec command, which now you're execing in like the little code app space, which is super cool. So this was fixed in Target SDK 18, but the developers are still using Target SDK 17, which you can check in the Android manifest. That's right, you can essentially exec things there. Really cool. So Emily talked about Wireshark. I like man-in-the-middle proxy because I'm really lazy. So super easy to install. Here's what it looks like. You can do it with HTTP traffic or HTTPS. Super easy. Install it, either brew or apt-get. On your phone, just set your default gateway to whatever your desktop is. And then you can navigate to, I think it's mitm.it, and then you'll download the third-party cert. You're golden. You can see everything. So here's another one. So the other talk I gave today was how to find root or how to get around root detection. One of the neat things I see is developers will write all these kind of tokens and session info to share preferences, which by itself is safe. But I think a lot of developers don't count on bug bounty hunters going through that. And now I know parameters to pass into authentication mechanisms against an API. Sometimes they'll have particular token IDs for querying endpoints. A lot of interesting things there. So one of the things I do is like I make multiple accounts and then see how those change, and that might give me some idea of how the web authentication works. And then I also have a bunch of values that I can kind of brute force an API a bunch. I can just swap those out quicker. I find that easier, but again, I don't have the web background, so that's what I do. Okay, IPC model is your friend. We're going to give a little overview of how IPC works on Android, and then we'll do a bunch of really funny flaws that hopefully will cement that. So IPC is your friend. What is an activity, a service, intent receiver, and a content provider? These are your four main building blocks of any Android app. Activity, super simple. If you like physically touch that phone with your finger and it's touching the app, it's probably an activity. So anything the user touches. There will always be one of these in every single application because when you press the little shortcut on an app, to launch it, something launches. That is an activity. Now, a service is a long-running process. It'll run in the background when the user is doing other things. So example I often use is something like Spotify, right? So Spotify will play music while you're browsing Reddit, for example, right? That's a service. An intent receiver responds to input. Input could be an SMS message, the phone rebooting, losing connectivity state. It could be a custom one that a developer makes too. An example here is if you're using Netflix and you hop off Wi-Fi, and you're on your data plan, Netflix usually will show a warning that says, hey, you're not on Wi-Fi, you're going to eat up all your data, are you sure you want to watch stuff? And that's an example of an intent receiver. There's also something called content providers. And this is a means of interacting with app storage. It's typically like SQL commands. I don't focus on this too heavily because there's a ton of tutorials out there, and Drozer will actually help find a lot of these as well. So how does one start another activity? Super easy. So what we're doing here, let me get my little laser pointer thing, is you have this send method right here, or send message method. And what it's doing is it's creating new intent. And intents are these objects that different Android components kind of throw around. It's how they communicate, right? And what it's going to do is it creates a new edit text object and says, hey, go find the one that matches this particular ID. And then it says from that text object, make the string message and set it to the appropriate value. And then it sets these attributes of the intent. So the extra message, and then it does start activity, and it passes this intent object in. And that's how a new activity gets made. Service, similar way. So you create a new intent here, and then all it's doing in the constructor is you're just passing the name of the service that you want to start. And it's just start service intent. And then I've also linked to the API docs that go into this much, much more lower level. Now, broadcast receivers are those things that I mentioned earlier. They listen for something. And typically, there's two ways of doing it. The more traditional way is you declare in your manifest. So this one, they have something called my broadcast receiver. It's set exported as true. I will talk about that in a little bit. And then it's doing things where this intent filters what it's listening for. So in this case, it's listening for boot complete, which means the phone rebooted. So there's some apps that like start as soon as your phone restarts. This is how it works. They have an intent receiver that listens for these. It can also listen for an input method changed. If you go to the Google APIs, it lists all the various ones an app can do. So once you declare it in your manifest, which is like your table of contents, then you actually have to do Java code that does this. And here's how it'll look. It'll look like something like this. You'll see a my broadcast receiver. It extends the broadcast receiver. And everyone's going to have this on receive method. And what that's going to do is take an intent, and it's going to basically inspect that intent, get attributes of it, and then do something based on what's in the intent. So in this one, it's basically get the intent action, and it's for, what's it called, new line. And then it's going to look for this URI intent scheme, cast that as a string, and then log something based on what was in the intent, and then do a toast. And toast is like a pop-up, right? That's all it's doing. So inspects the intent, writes something to a log file, makes a toast, done. You can also do it dynamically. And this is a cool one that not a lot of people look for, in my opinion. And you declare it like any kind of object. So how this one works is you'll see a new broadcast receiver, and then they'll do some kind of intent filter. So this one, they're basically looking if airplane mode have been changed on and off, and then they register a receiver. Now it should be note that these context registered receivers, they only are listening as long as that context is valid. One of the vulns I found, it was a Office like mobile app where you'd write like a little Word doc, and then you could like save, print, convert it. What I found in that one was when I started conversion, so say I had a Word document, I then want to do file save as PDF. When I hit the file save as PDF, it would create a new intent filter that would listen for a custom intent that basically indicated, hey, the file conversion is done, and then it would stop. I'll get into a vuln associated with that later. So now we get into explicit versus implicit intents. So I grabbed these from a really great DEF CON talk called 7 Ways to Hang Yourself with Google Android. I think it's about an hour on all these low-level things. I'm only going to skim some of it. Explicit intents means the recipient of that intent is specified. So you say only this app or only this broadcast receiver can take it. Okay? Implicit intents is it's left up to the platform to decide where this intent should be delivered to. So if you guys ever used an Android app and I don't know, maybe you open a web page, it says, what do you want to open this in? Facebook, Reddit, Chrome, Firefox. That's an implicit intent. Okay? Now, fail-orama time. So we're gonna talk about what that exported flag means. we're going to go through broadcast receiver fail, export activity fail, exported service fail, and then I think one more on a web to intent fail. Exported TLDR means your app can interact with something else. This is from Mobile Application Hackers Handbook, Chapter 7. Key thing here is if it's less than the API 17, you can do some cool stuff. By default, everything but content provider is not exported. But if it's less than 17, it means it is. So what does this mean? If you see target SDK 17 or lower, or sorry, should be 16 or lower, in the manifest, any content provider is exported, which is really cool. So if you see something like this in the manifest, provider Android equal name, com something that app, authorities equal com something that app. Even though that developer didn't say exported equal true, anyone can send junk to that, which is really cool, right? And this is bad because your content provider essentially allow you to access like application storage in that SQL-like language, right? Super easy find. Another one you can look at is receivers. So anything in your manifest, you can specify exported true or not. So this one, you have a receiver com.something.app. Exported is equal to true. This means any other app on the phone can send intents to that receiver. Another thing, any app that uses an intent filter is exported, right? Because you're basically saying, hey, listen to only receive intents with these kind of things, right? Well, that makes it now public, right? There's things you can do to not do that, but just be aware of it. So let's take an example. So this one, even Android name, some activity, image activity, and you're doing a filter, right? So if you see this intent filter one, it's stating how you communicate with this, right? So this one's saying, hey, it's looking for android.intent.action.send. Dozer is a phenomenal tool. It's a little app you can put on your phone and runs like a Python client-server model, and it will help enumerate all the things I just mentioned. So you just do, I think it's called scan surface area. It'll tell you every exported in activity, service, provider, and receiver in the manifest. You won't find those dynamic receivers I mentioned, but it's a great starting point. And also, it'll allow you wrappers to interact with these. For the next examples, I don't use Dozer. I should have had to do it manually with some of the shell commands, but you can do the same thing. So first failing scenario, intent receiver fail. Again, this is from that 7 ways to hang yourself slide deck. Say we have our little evil app, okay? And we have a good app, this IMDb app. And the IMDb app will listen for the location of a user, right? Because you give it a location, it says, oh, here's what movies are playing in your zip code, right? So Sam wants to go see the Emoticon movie or whatever. The app gets his location, and then it'll pop up in IMDb what the show times are. Now, the problem is because it'll accept an intent from any app, as a bad guy, I can send bad data to that, right? So in this one, the bad guy sends this bad location intent. And if you actually look at the GUI, you'll end up with the one on the right where nothing is shown. That's just because the intent receiver is open, right? So typically for bug bounties, they want to show some impact, right? Like you can always send junk. They'll probably crash a lot of apps, but they usually want a way of, okay, you're ruining the person's functionality of this application. So here's a really cool one. This is abusing export activities. It was CVE 2013-627. Essentially, you could get around the Android lock screen. It's a great example because one, it was like in actual Android of every distribution for the era. And it's a great example because it's trivial to make this kind of mistake. So we're going to be using this command right here. First is ADB shell. ADB shell, it's part of the Android debugging bridge. It comes in the Android Build Tools SDK and allows you to interact with the phone over USB. So shell basically means it's a shell. We're going to be executing some commands here. And also this example, if you go to the link on the bottom, I will share the slides. It has a much more verbose walkthrough as well. AM start stands for Activity Manager. And we're basically saying, hey, start something. I will give you how to start it. Next is the name of the activity we want to start. So in this case, the first chunk of this before your slash is com.android.settings. This basically means the package is called com.android.settings. The next part after your slash is saying what's the actual activity you want to launch. In this case, it's choose lock generic. So here's the code for it. Notice a few things. So we have a value, this confirm credentials. This is what we're going to be messing with. So what we can do is when we start an activity is we can give it additional parameters. So EZ stands for the Boolean value. And we're going to say confirm credentials is false. Now this is the opposite of what it defaults to. So let's look at our code here. So confirm credentials is going to be false because we're giving it a bad value. And there's something called mPassword confirmed. And that's basically set to the opposite of what we give it. So we give it false, that becomes true. mPassword confirmed is now true. And this brings us into our password confirmed method. So password confirmed gets something called quality, and it's looking essentially for an integer with password key, and its default value is -1. Well, again, we can control this, right? Because this activity is exported, anyone can send stuff to it. So in this case, we're sending EI, which stands for integer, lock screen type, the key, then a value being 0. Okay, cool. So first there's a check to see if quality is equal to -1. It's 0 because we handed in that weird value that dev never thought about. And because of that, it ends up in this else statement that ends up calling update unlock method and finish. And we're going to pass in the value 0 for quality and false is hard-coded in. So now we end up in this method, update unlock method and finish. So a ton of conditional statements. I won't go through all of them, but eventually end up in this one, which will be executed with those two weird values. This one basically says, hey, if it equals that 0, 1, clear the lock, which means turn off, unlock the phone, set lock screen disable, which turns it off completely. So if you had a pin, you would just turn that off, and that's it. So what this vuln allowed people to do is essentially this old version of Android, any other app, if you had a pin, could just turn it off on a whim, which is really cool. So if Google could have this mistake, probably others might have a similar one. And essentially what we're doing here is think of an application, something generic. Like you have a main activity, maybe it's a game or a bank or something. Then you have some kind of log on or something, and then something that's not public, right? Now, I would implore you to look at what the parameters of the activity that is doing that initial validation are. There might be weird values like the scenario we just walked through. And by providing values in such a state that a dev never considered, you could end up in an area that was never inherently public, which is kind of cool. So this is our entry points that we can attack apps from. So here's another one. This is from Tim J. Case and Caleb's training in Vegas. This is like 4-hour training. All the training's up on their website. So here's an abusing a service one. So this one was a service. We got this from the Android manifest. It's something, some Qualcomm app. And you can see here, remember there's no exporter or anything like that. We know a filter, and we know how to send things to it. So first thing, we'll look at the service on start command, which is the first method that is always invoked every time a service runs. And it's taking the intent. First, if the intent is null, the service stops, right? Which is kind of funny. Now, within, 30 seconds, easy denial of service. But we want to do something more interested in this case. So then let's look at the next conditional statement. If the intent has a string that has the para, P-A-R-A, then go down this code path and call this do system actions. This is interesting. So let's look at that. So it takes para, which we got from the intent that anyone can send to this service. It does make sure it's not null. If it's not null, then it just splits the string where the comma is. And then there's a call to set system properties, and basically wherever that split happens, it takes the first and second one and throws it in there. And on your set system properties, remember we have our two strings that we split up from that intent. We have key and we have a value. And what's cool about this is it checks if they're not null, and then it sets system properties. And this is a cool one because this is a application that runs at a higher privilege on certain devices. And now we're setting system properties that any generic app should never be able to do, right? So I like this one because it's really reasonably simple. You saw how a simple service based on the permissions of that app could do additional harm. So I think that one's pretty cool. You can also spy on intents. So if an app doesn't make an intent explicit, other apps could quote unquote spy on it. So let's go back to our IMDb example. Okay, Sam really wants to go see the Emoticon movie in SF. He wants to put in what zip code he is so he can go see it. All right, so he does the Showtime search, and the developer doesn't explicitly say who can receive this intent. Right, so here's what it should look like. You know, boom goes to it. Now, because they don't put any kind of constraints on who can listen to that, any other app could listen to see what's in it. Now, most intents are probably not much good things, but if it's intent that contains, I don't know, credit card information or location coordinates of a user, that could be more valuable, right? So in this case, IMDb app sends the intent, and then my EEL app will listen to that and log any of that information. So in this case, I could always get the location or the zip code of the user running the app, which I would say is a PII violation. So here's an interesting one. We're going to combine some of those web skills we talked about earlier. So this requires the set allow universal access from file URLs. I mentioned that string earlier. And what's going to happen is we're going to have a payload. And our end goal is I'm going to find some code that will respond to any kind of file colon ///. And then we're going to make the app go to a bad website, and we're going to do something because JavaScript's enabled. Okay, and this will allow us to steal file intents via the browser. And this is how you would do it. So we would look for something that has a web view. It has set JavaScript, so we know it's rendering JavaScript. It's set allow universal access from file URLs. And it's getting an intent that's from URL one, right? So we have an activity. It'll listen for an intent. It'll parse that intent and go to the URL that's in it. Well, all you got to do is put an intent that says, hey, go to this /data malicious app page or somewhere on the phone. It could be SD card. It would go to it. It would render it. Any JavaScript on the HTML will be rendered, and you might be able to do stuff there, right? So this is cool because this breaks your Android sandbox model, right? So say you had like private tokens or files you don't want getting out. They're levering, if they are doing this, then you can extract that out of that safe little container without rooting the device. I think that's a cool one. So bonus native code content. So everything, Tim touched on some of the non-native code things here. I'm only going to talk a little bit. But if you're familiar with buffer overflows or any kind of x86 or ARM, this will actually come in. And I found this actually at Lookout, which I thought was kind of funny. Developers can use vulnerable versions of GCC. My coworker Vitaly helped me a lot here. So I didn't know this. Stack protections, like your cookies, stack cookies weren't available in GCC until version 4.9 for all the architectures, which is kind of shocking, right? So this is 2012. So I was like, huh, that's interesting. So it turns out that you can see GCC version 4.9 was June 26, 2015. So one of the tricks I actually like to do is run strings on your SO files in the /lib directory. If you see they're using that old version of GCC, and if you can find a buffer overflow, there won't be any protections. So super easy way of finding something there. You would have to then find a buffer overflow, rewrite your necessary return addresses, but yeah, but then you're running within the context of that app, which is really cool. So I have some time for some questions now. The Twitter is @Benra, email is ben@cybermerchantsofdeath, and yeah. Let me go back to see what all you guys think.
It looks like we had at least one question in the Q&A widget there.
Oh, for dynamic. So the question was, in case of dynamic reverse engineering, what's your favorite tool for approach? I use Exposed framework a lot. Any recommendations? Exposed is phenomenal. It's a great way of hooking a lot of API calls without having to learn the debugger, What I like a lot is Jeb. You can get a monthly license for 120 bucks a month, which is really nice. If you send them a Christmas card, they might give you a discount. And that's nice because you have like all the powerful tools of IDA for only $120 a month. So you could kind of say, look, I'll try this pay tool for a month, see if it's worth it. Can I find any bugs on it? There's a lot of great exposed frameworks for hiding from root detection and SSL pinning, right? The downside is a developer can see that and easily circumvent it. What other good tools are out there? Frida is another phenomenal one if you want to get into that. How to develop malicious Android app for PL. I'll answer that one too. Frida is a really good one that allows you basically, if you know a little JavaScript, you can say, hey, anytime I see this method, that method could be opening a WebSocket, an encryption key, print out that info. So Frida is a great one too. IntraSpy, you used to be able to do a little bit, but you need an old version of Android. Unfortunately, you need like an Android 4X device. And even then, sometimes you have to turn off SE Linux, which is a pain in the butt. So those are the top ones I would do. So you can continue using Exposed. I would highly recommend Frida. It's phenomenal. And then Jeb. If you could afford it, IDA Pro. But Jeb will get you a lot of similar ones. The other question was, I guess I should click I answered it live, if you like that. How to develop a malicious Android app for POC. So the nice thing is how I got into reversing Android was actually just go to any of the sketchy stores and download the malware and then just look at it, right? So the nice thing about we looked in a lot of these is it's very trivial to reverse, right? The same techniques I used when reverse engineering malware, I got a feeling of, okay, how do I easily identify how someone's writing a file to the SD card? How are they doing SMS command and control? Same ideas apply to your bug bounty skills. So the nice thing is you don't have to know every Android API under the sun. You just have to know the ones that will cause mistakes frequently, right? So those can be things such as the crypto ones I mentioned, the HTTP ones, what else? The web ones, right? So you really only have to know certain particular APIs. Same with the malicious ones. Does that answer your question? Cool. Yeah.
Hey Ben, I have a question for you.
Shoot.
It's a silly one, but
Go ahead.
You guys have focused mostly on Android. Do you find that the skill sets are completely different, or do you find that someone who can work on Android can also work on reversing iOS apps, or it's pretty much split down the middle?
So iOS, you have a little bit higher barrier to entry because unfortunately a lot of the times you're going to be looking at the ARM disassembly, and that adds a little bit of a barrier to entry. So if you're a very motivated person, if you go to the opensecuritytraining.info website, they have a 2-day intro to ARM class.
I love that class, by the way.
Yeah.
It's so awesome. Can you post that link in the chat?
Yeah. I'll post that. So if you watch that, then you'll know basic assembly, right, for ARM. Most of your iOS you're going to be looking at that way. The most inexpensive tool I would use for looking at iOS is Hopper. So that's $99, right? You could use Object Dump if you're a masochist or like a 6-year-old Unix admin. You could do that. But I would say Android's easiest just because the barrier to entry is lower, right? You can use the emulator. You don't need to have a Mac. If you've taken any kind of rudimentary Java, that's very helpful. If you're doing iOS, you need a little bit of a C background because you're going to have to do things like pointers and your memory management. You're going to have to know a little bit of your nuances of Objective-C that I think Emily talked about. And also the other downside is to decrypt apps, but yourself, you need an iOS device, right? So not only do you have to get an iOS device, but you need to get a one running a vulnerable version of iOS that you can jailbreak. And that's a pain in the butt even for, researchers with full-time jobs, right? Because I have to go to the Apple store and say, like, give me your dustiest iPhone in the back, hoping that it'll be, 2 or 3 versions behind on iOS so I can jailbreak it.
Yeah, it's usually Craigslist for me where I go to try to get my...
Yeah, and that's a pain.
Yeah. Very cool. You guys dropped, you guys still work together or you're just separate in a group of friends now?
We're all separate groups of friends, so it's actually quite funny. So Tim hired me at Lookout. Emily was our intern. And we all keep in touch, right? And like there's little meetups, and all of us are very available on Twitter if there's any questions. Like I bug Tim all the time. Like I used to be really bad, and I just kind of stuck with it. So.
Well, you guys dropped a lot of mobile knowledge today. I'm so happy that you guys came and presented for us because it's just sweet. So
yeah, and I recommend students check this stuff out. Like even if you're just approaching it from a learning perspective, and like say you're, I don't know, reversing a really hard banking app, right? And it's just you're getting frustrated. Go look at, I don't know, like a North Korean or like some really tiny banking app where they have no protections, and kind of work your way up, right?
Cool. All right. Well, we're about 5 minutes over, so we should let the next presenter come in here.
My bad.
Sorry. No worries at all. No worries.
No, you're cool, man. You're cool.
Cool. All right. Good luck, guys.